let's first start before we dive into AI. Maybe let's first point out some of the Earth observation trends that we're seeing. And maybe we can start with Kumar. So what are the latest trends and advancements in Earth observation market? And where do we see the market going in the next 5 years? And maybe you can also comment about the Legion satellites that will be, again, providing the 3D mapping of the world as well. So we'll be happy to learn about that.
Thank you, Nicholas. Actually, it's very, very exciting, not only for Maxar, but for the new space industry in general. From a Maxar perspective, if I give you a quick rear view mirror of the past, what has happened and where we see it going. So in the remote sensing industry, we talk about spatial resolution. We started with 60 centimeter satellite with QuickBird, and then we launched 50 centimeters with WorldView 1, and we have WorldView 3 and our Legion satellites, which we'll be launching later this year. They're all at 30 centimeter resolution. This is just Maxar right now, where we are pushing the boundaries of spatial resolution. The next one is what I call spectral resolution. The initial satellites have 4 spectral bands: blue, green, red, near infrared. And then we added 4 more on WorldView 2, just in the visible and NIR part of the spectrum. And then on WorldView 3, we added a total of another 8, total of 16, but in visible, near infrared, and shortwave infrared. So you can actually start seeing the trend that we're trying to put spectral resolution in multiple bands so that we can gather more information. The one that's exciting with Legion is that there'll be a constellation of 6 satellites. 2 will be in sun synchronous, and then the other 4 will be in the mid-inclination orbits. Mm-hmm. So the reason we are doing that is if you add our current WorldView constellation of satellites plus Legion, depending on where you're on the planet, we can come back up to 15 times a day. An example would be around equator, we come back around 10 times. For most populated areas of the globe, we're coming back 12 times a day. So now let's talk about the essence of what we're trying to do here. Is right now we have a little over 135 petabytes of data. We've been collecting since 2000, right? Big data, big data. So the key point is when you're trying to do analysis, right now I think we can actually start thinking about doing global scale analysis very, very frequently. So now let me put my hat as watching the new space. When Apple first started, their slogan used to be, there is an app for that. And I think we're at a point in new space, there is a satellite for that, is how I say it. You say if it's a thermal, I mean, you name it, every modality, multispectral, superspectral, hyperspectral, you have satellites there, small satellites. You have satellites collecting the entire globe multiple times a day. And then you have satellites in thermal, you have satellites doing radio occultation, radio frequencies, SAR. I would say that where I see the future going, I think the number of companies launching all kind of modalities will increase. And at the same time, the focus of this panel, I think, is where everything is going to go is, okay, now you can collect the data. How do you bring it down as fast as you can and start bringing the insights? So fundamentally, our philosophy is that there are not enough human eyeballs to be looking at all these imagery. So AI ML is going to play a big part in getting the right information to the right person as fast after the data acquisition.
Perfect, wonderful, Kumar. So thank you for that again overview, and it's very exciting to see the how Maxar is again introducing this new satellite fleet with Legion, and I had a great conversation about that with your colleague as well. Last year he was presenting at ISC 2022. So that's amazing. So now maybe Sangdown can answer me for the next question, and I would love his input on that as well. So how is Earth observation data in general, spaceborne data, aiding governments, corporations, and individuals in making those better decisions and more accurate decisions? As we see in the latest trend that we saw was that once this conflict began with Russia and Ukraine, a lot of companies, especially one of the companies that has been posting it publicly on LinkedIn and other platforms, has been Capella Space, and they've been providing again this imagery where we could actually everyday individuals just see what's happening there real time with the imagery. So that's more for a military applications. Maybe you can touch upon that as well, but general over industrial applications as well. Sangdong, maybe you can provide insight on that, and Kishan can also then chime in on that as well. So
okay. As a Starburst, we are still the only global aerospace and defense-related accelerator and venture capital company. Then we can see a lot of trends in AI plus space plus some defense area, including our portfolio companies also. And then one of the AI is very important for space market. And as you said, a lot of things are being analyzed by AI capability or machine learning or the big data techniques. Without that, we cannot do anything with that kind of tons of information poured from the space. But on top of that, what we are observing is that as you mentioned, during some emergency cases over the Ukraine or the other disaster area, then government needs to consider space security also, because everybody can see the other everybody's area. Then we need to be really careful how to protect our not only our own space asset, but also ground assets in the viewpoint of the national security. And also regarding the peaceful use or the civilian use of the space data, then as I think Kumar mentioned already about that one, how to get intact full information from space is also important. So remember, referencing our own terminology in Starburst, we call it as a enabling technologies, which supports the other space or the aviation or defense specific category product or solution. We call it enabling technology. And for this, AI itself is also one of the enabling technology. But for this AI to be really powerful for any purpose from the space asset communication, then the communication plus the data security, cyber security technologies are the enabling technologies for AI also. That's my opinion.
perfect, wonderful. So thank you for that opinion, Sangdong. So Kishan, maybe you would like to let us know again from your standpoint and from your expertise. What are some of the specific examples of uses of, let's say, spaceborne data in adjacent industries, and how much growth does it drive in those sectors?
Sure. Yeah. Thanks, Nicholas. Yeah. Thanks for having me here. And firstly, I'll tell a bit about myself and
Sure.
Galaxy. So I'm VP Engineering here at Galaxy, and at Galaxy we are going to launch a satellite, multi-sensor satellite carrying a synthetic aperture radar and a multispectral imager, providing high resolution images of the Earth, and in near real time when the constellation is up. So we are planning to have the first satellite up in space by Q2 of next year. And we definitely believe that AI and ML has a big role in making sure, helping us achieve this. So firstly, there are many applications that people have already tried. People have already put in space various computers, or we call it edge computers, which can enable. Some of our partners have already done that, who are helping us build the satellite. And I think it is essential not to jump into what applications, but how we can actually achieve this in a proper manner. Because as of now, AI has been done in space, but not for Earth observation. But if you see what for rocket landings, for various for orbital maneuvers onboard satellite control, there are places like that where AI is being used by companies. But that has came after years of research and making sure that the models that are running have a very high accuracy. And in order to have that much confidence, firstly we have to do a lot of testing and potentially use the hardware that is already in space, test out a lot of applications, and various places where we can start off as simple algorithms, something like building detection or like predicting crops, how the crops can be, when crops should be harvested. Some other places where AI can be highly important is in natural disaster, where you do require that data immediately. And something that you already said is in defense as well, where you do require, you want to know what is happening in the at the borders as soon as possible, and there if possible, like object detection algorithms is something that can be tried out, but they need to be tested a lot before we can say it is a standard in for Earth observation.
Perfect. So, and as you mentioned, Kishan, so the AI has been already being used in the industry for a while in some applications, but not specifically for Earth observation, right, and processing maybe. And what are some of the biggest challenges for utilizing AI for the Earth observation data processing and extraction? So that's a question. And whoever would like to take that, maybe Kumar, you would like to go ahead.
Yeah, let me start and then hopefully the panelists can chime in. The biggest problem you have with all these kinds of data is making it analysis ready. I'll give you an example. A lot of our satellites, we look sideways and take pictures. So that means I might be looking at the sun today, I might be looking away from the sun tomorrow. So the same object will have different spectral behavior and spatial behavior depending on the viewing geometry of the satellite and where the sun is. So how do you basically make sure all the data can come together? And by the way, typical estimates are 80% of the time spent by analysts is preparing the data. Mm-hmm. So as we talk about these petabytes of data, ensuring that the data is spectrally, spatially registered and ready for analytics, I would say would be the key challenge. And then taking the current techniques and then modifying them so that you can start accounting for the variability of what we call bidirectional reflectance function would be a key challenge as well.
Perfect, thank you. So Sangdown, maybe you would like to add on that.
Yes, I think the Kumar's question is really accurate or important, I think. So as an example, how to analyze, I think that's really important. And up to now, mixing some of my own personal observation to this industry, I think the human power is really important for artificial intelligence because in two reasons. One reason is the very powerful mathematical plus software technology to minimize such big data analysis. The other part of the technology or the really human resource spending is to determine whether the result is okay or not. Then a lot of manpower or the man hours needs to be consumed yet for this part. So this part of the a lot of the time consuming works may be reduced through the automated AI decision, but still, and coming back to first category, for this time spending hours needs to be reduced, then again, the very smart human implicate the incorporation of the human mathematical logics into AI software is important. So as a summary, I would like to say human power cannot be excluded from AI technology.
Mm-hmm. Absolutely. So yeah, human input is necessary because AI cannot really make decisions for its own just yet, right? So that's just yet.
Yeah,
as
it's
well.
Just a tool up to now yet.
Yes, absolutely. So that's great. And another challenge, which I see personally, and that's a also challenge, but that's also an opportunity. There was a recent study, well, not really recent, just a year ago, I think, that linking basically the AI process data and Earth observation data with the economic implications of those processes, right? And especially in regards to the climate change, there was a report how floodings in I think California impacted the increase of the price of the French fries in Japan, which was very, again, interesting, right? So how do you believe can the basically experts of the industry come together and cooperate with those institutions or stakeholders to, again, monitor and track precisely this data and this implications, which is going to be much more bigger than those petabytes that just itself the processing data is of the Earth observation. Now imagine we also linking it to all sorts of other industries and all sorts of other implications in the supply chain. So what would be the best approach for that? That's a question, to collaborate and really figure out how we can monitor that and really create this tracking algorithms.
Okay, let me start on that. Yeah, so I guess I'd read a news article earlier where some people, like similar to what you said, some people were monitoring the amount of cars that were parked outside Walmart, and they're figuring out the stock prices of Walmart, how they'll increase or go down, and like so things like this. There's application for people, the companies who actually check the oil that is being stored in places like Rotterdam, and they figure out how they can predict these things, like how oil prices can go up or down based on the store before they actually come out in the market. Yeah, so definitely in a small bits and pieces, people are doing these analysis and like figuring out how one thing is affecting another. But a major bottleneck for that, I would say, is that they are very focused and for a particular application currently, and in order to see how one thing is affecting other, like for example, you said like forest fire, like floodings in California affecting that does require very deep research, and currently and a lot of openly available data as well for the people in order to do that thing. Then only, like, that is one thing that is very necessary, is that if a lot of this data is made available to researchers, then these predictions can be made possible, and soon they can be made accurate as well.
Perfect. And would Kumar like to add to that as well? I think he's unmuting himself.
Yeah, one of the interesting things I say is that the good old saying, a picture is worth 1,000 words, right? And each of these markets, each of these applications require those 3-5 specific words, very specific to the application. At this point, the AI/ML techniques might be good at one thing, but they're not good at everything yet. So that's part one of the story. Part two is actually the market itself. A lot of us who have actually been in the industry for a long time, we talked about 120 plus applications of remote sensing data in 1998, if you may. But there are only 5-6 select markets that actually can pay for these kinds of things. So you need to also look at, while the remote sensing data, by the way I look at that is remote sensing is observing the physical geography of the Earth. And for other things you're mentioning, you need to think about socioeconomic and environmental factors. So you need additional data sets to complement the observations from space. But I think we also need to look at, is the industry there to actually support these kind of analysis and pay? Because when you talk about satellites, they're absolutely expensive when you talk about launching and building these kinds of satellites.
Perfect.
Yeah.
Yeah, go ahead, Sangdong.
Yeah, just to give you a very short opinion, I think the AI and the human interactive learning is also important regarding this topic. As an example, one of our Starburst portfolio company named as a AI Redefined, or AIR, which is specialized at the human AI interactive learning each other. So as Kumar said, the currently each AI cannot cover the other area, but human also cannot cover all the areas. Then the learning each other from AI's big data capability, and AI is learning from humans kind of the insight, and then we can develop together for the better future, and including the monetary market also.
Perfect, wonderful. And my next question is with the AI, obviously, and the level of automation that brings in, right? So, how can space industry professionals ensure that the AI algorithms that they develop are reliable and they're unbiased, that they yield again the same correct results every single time, and it just doesn't give you different results of the same processes that are occurring? And also, how do they make sure that it complies with the data privacy and security regulations and compliances?
Yeah, I can start on that one. One of the things we have been doing at Maxar is even a simple object detection. This could be detecting planes in an airport, right? It's a known problem with known objects. And it took us a lot of training, sometimes 35,000 samples to get to the kind of consistencies we're talking about. Now we actually run it almost on every image we collect so that we are confident that those models work for that particular object. That's on part one. This is where we are actually employing synthetic data sets. As you know, the geography changes a lot. Same object in different geographies need to be trained. So we are using synthetic training to basically complement and start recreating those kinds of geographies to get to those. So the other discipline people are working on is what we call explainable AI. Okay, right now, a lot of people treat AI as a black box. People want to understand what is actually happening. Why is AI coming to the conclusions it's coming to? So, and then that both of those actually lead to what we call trustworthy AI. By making sure that you can rely on it consistently. So I would say for Earth observation, we still have ways to go. There are certain objects we can detect with very high confidence, but there are others I think we have ways to go. And just to add to what Sundar was saying before, I think at this point, I 100% agree with what he's saying. I think AI is more augmenting human intelligence. So it's augmenting intelligence. Eventually, it will turn to AI artificial intelligence at some point. But for Earth observation, we are in that AI in this augmenting intelligence phase where humans need to train. And I think even that, the number of samples required is huge. So, but I think the process is where reinforcement learning, these kinds of things are coming in so that you can actually start thinking about a trustworthy AI models.
Yeah. So yeah, adding to that, since the Kumar mentioned about optics, so one of my experience beforehand is the optics related defense area. So at that time, we have a kind of the detectable, identifiable, something like the criteria set up by customer, or it is kind of the sort of the standard in that industry area. So similarly, regarding the AI's capability to determine anything from the Earth observation data, then I guess we need to set up a kind of for the civilian purpose, agreeable criteria for AI's decision. And the second one is more related to some the secret business between customer and each AI company. One of the terminology I would like to use is the XAI, explainable AI. Then from the AI's result to our customer, we need to explain why this AI's result is reliable. So that's my opinion.
Mm-hmm. Perfect. So Kishan, would you like to add on that as well?
Yeah, I agree to both of their points, but I'll just go back to what Kumaran had said earlier. Is like in Earth observations, you do not know how the data you do require. You do need a lot of pre-processing in order to make sure that the data is analytics ready itself. Like there's a lot of atmospheric interference that can happen. There are a few things that can go wrong at the sensor level as well, like at a few pixels, and that can there are requirements in calibrating the sensor from time to time. And so that is why for us, we need to reach that level where we can firstly do all of that as well on board the satellite. Apart from that, another aspect is that people have showed a lot of progress in AI for RGB images or multispectral images, but there has been very less efforts for AI for SAR. And that is why the satellite that we are launching for a multi-sensor base is complementing not only in information, but also for analytics in a sense. An RGB image can be used to train a SAR image and simultaneously other one, where now you have two sources of data for reliability once they are trained together, and that can improve the accuracy much better. Yeah, I think
I see
Kumar wants to
Kumar is
add.
raising the hand as well.
Yeah, Nicholas, actually what Sangdong said triggered this four-step process in AI ML. By the way, I belong to a group called WGIC, World Geospatial Industry Council. We just published a white paper on these approach. So when you talk about AI ML, and I'm talking about our kind of data, the four different phases are, the first one is descriptive. You're describing what's in a given image or a given scene, whether it's SAR, electro-optical, it doesn't matter. The second logical state is diagnostic. Why did 3 planes show up instead of 10 planes? Maybe it's because of COVID. That's the next evolution of AI ML. And then eventually it's becoming predictive. Once it understands that, okay, it's a Sunday in Colorado where I am, that means that these are the number of planes I expect at this airport. And then eventually prescriptive. This is where it's actually prescribing. When you start trusting the AI ML models and the answers, then you get into the prescriptive. As Kishan was saying, by the way, prescriptive models are already used in airport engines. So technology of AI/ML is being adopted elsewhere. For space data, I think we have a little ways to go, but I believe the next few years we will be there.
Perfect, wonderful. And we've been talking a lot about the AI applications for the Earth observation, but I don't want to change the theme of the panel here because that's the main theme, but maybe we can also just slightly touch upon other applications of AI for the management of those space-based assets that we have of the satellites and the fleets. So I believe that's very important, and also the applications in the space traffic management and collision avoidance as well for artificial intelligence. I'll be happy to have your input on that.
Yeah, I can jump on that one, Nicholas, because only last week I released a product on non-Earth imaging. As you look from space, our telescopes, I'll give you an example of WolveView-3 satellite, we can take 30-centimeter pictures of the planet. But when I turn the telescope up and start looking at space objects, they're much, much closer. So this non-Earth imaging is for space object characterization. We're able to actually image it at 2.5 to 10-centimeter resolution, very, very detailed objects. So one of the things we have been working on is modeling and simulating the various objects just in LEO. If you're familiar with the whole space debris problem, there are around 35,000 objects that are being monitored by different agencies and different companies across the globe. And depending on who you talk to, there are up to 1 million pieces of debris all the way from 300 to 1,000 kilometers in LEO orbit. So we need actually a lot of AI/ML models that can start understanding the space situation awareness or space domain awareness. And we're actually participating actively in scanning the space, not only for what we call resolved objects, which we know, and then unresolved objects. These could be smaller than 10 centimeter by 10 centimeter. But at the end, if you followed this Monday, International Space Station had to maneuver because one of the US, it's a Argentinian satellite company, satellite was heading to ISS. So the whole modeling and simulation plus space traffic management, as you have more assets being deployed, and then things like tugging and moving things around, on-orbit repairs, all these things are coming into play. So by the way, when I talk about that, it's not only in LEO, it's LEO, MEO, GEO, and XGEO, which could always go to lunar space as well. AI/ML can play a key role in modeling and simulation to understand where these pieces are, where the objects of interest are, so that you can do space traffic management, object maneuvering, collision avoidance, all those kinds of things.
Wonderful. So Sangdong, would you like to comment as well?
Yes. So beyond such kind of the imagery based data and Nicholas, as you questioned, I believe the what we call as a adaptive control might be really important and interesting subject for AI engineers plus control engineers to study on. Adaptive control means not based on the preset gains for control, but the adaptive control means the through whatever machine learning or AI, for the unpredicted condition, this system or machine can control itself. As an example, currently lots of drone companies are studying about that one. Nobody knows which kind of situation drone may be encountering during its mission. Then once some damage or something is happening around drone hardware condition, then adaptive control jumps in and to bring it back safely to the main base. That's kind of the adaptive control. And plus, regarding the space condition, as we will be exploring Moon and Mars soon, then the first of all, the unmanned machine will be there as the NASA is doing on Mars. Then there will be huge time delay and also adaptive control plus some level of self-decision by the machine, by the AI. It will be also important case. I cannot name any specific situation beyond the adaptive control, but I believe the self-decision making capability will be really important for the future.
Absolutely, especially if we're talking about again distant missions as well, where we cannot really in real time monitor again the decision of the robotic explorers. And if we're talking about the Mars exploration also, and also regarding the asteroid mining missions, that's going to be a huge application for the artificial intelligence as well. And because robotics very challenging, AI very challenging for those missions, so it's going to take a lot of research and development to accomplish those missions and to get to that stage. So another of my question is how important it is that the space companies, especially the satellite operators for Earth observation, are cooperating collectively with the other companies which are specifically developing the AI technology, and also with other companies that are developing software solutions, and that they integrate those solutions together to create the products which are tailored towards Earth observation and improving again the efficiency and the quality of the data that is produced.
Yeah, hey Nicholas. So yeah, it needs a at the end, any satellite company, they are getting their revenues out of these companies. So it is very much required that any satellite manufacturer does listen to and cooperates with the analytics companies and the companies who are making softwares and get an understanding of the end user as well. And not only at the AI level, even the payload that is being built needs to be made sure that it has capabilities and it has the specifications in terms of the image quality that is required by these analytics companies or the analysis that is going to happen in the overall end. So it's a back and forth that needs to go before a satellite is launched, and all the companies, they do take that decision and mainly try to generalize a data product that can be used for various specific applications. Yeah, and so you can see that in some of the satellites that have gone there, satellite specific for monitoring forest fires, there are satellites specific for object detection from space, like high resolution, and there are satellites for weather monitoring. So these can do require high collaboration with the companies that are actually building the analytics on that data.
Perfect, wonderful. And my next question is, this is more a bit to the public that might be worried with the artificial intelligence overall and some of the conspiracy theories that we have. So how do we make sure that again, the AI applied spacecraft, they are fully being, again, controlled and they're safe from, again, unexpected behavior, as they would describe it?
May I answer that one?
Sure.
Because one of my personal hobby is reading science fiction a lot. And then I witnessed recently, as Nicholas mentioned at the beginning of this panel discussion, the ChatGPT. I saw lots of the bad intentioned people, not that much bad, just a light-based as a joke bad. Then they are teaching the GPT to speak about bad things or some strange things. And as a result, what I said in my full discussion today is the human's intention is really important. And which type of human, how to teach AI, that drives the final result. So once the AI capability is given to some really bad people and they are training this AI to bad direction, it's uncontrollable, as you know. Another example referencing from drone side is that, with the same drone, some bad people may use it into bad purpose, but with the same drone, many people can use it very humanitarian purpose, like the life saving or the observation. So it purely depends on not AI's capability, but humans' intention or users' intention.
Yeah, I'm going to add
the coding and the script, obviously. Yes, absolutely.
Yeah. I'm going to add a couple of different perspectives on that. The first one is there are always, I would say majority are good apples, and there's always those two, three bad apples that cause what like Sangdong was talking about. So there is a whole group discussion going on about ethical AI, right? What we do with AI. So I'm actually pretty encouraged. There are several organizations that are trying to do this. And then in terms of coordination, I know of several consortiums. Maxar is part of few consortiums. UN-USA, for example, United Nations Office of Outer Space Affairs. There are few organizations that are also bringing entities together. Another example would be Secure World Foundation. So I would say that there is enough awareness across the globe. I'm looking at various global consortiums that are starting to address this. But the last piece is there's a policy aspect of it that needs to make sure that people are following it. This is where the debris from small satellites, FCC controls here in the US, but one company went ahead and launched it from India and violated the whole license, right? So I think I would say the policies play an important role, and globally countries are coming together to tighten up as well. So between ethical AI and then policies, I think I'm seeing good progress across the globe.
Perfect, wonderful. All right, so I think we're nearing to the end of the panel as well. So if we could just summarize each one of you by a couple sentences, maybe what type of game changer is AI going to be over the next decade and next coming years for the Earth observation market? And maybe we can summarize by a couple sentences from each of you.
I can go first. As I mentioned before, there are not enough humans and eyeballs to watch all this data. So AI and ML, I think primarily starting with ML, will play a key role in analyzing the data. And then by taking advantage of other technologies like Shandong was talking about, this includes the intersatellite links, onboard processing, edge processing. AI, we can imagine that the right information can be passed on to the right people very, very quickly, probably 2 to 5 years from now, with AI ML playing a critical role in that.
Perfect. So Shandong?
Yes, as a summary, I see again, would like to emphasize that the human education is also very important, not only about detailed codings. So for the next generation and for the AI to be developed further and for entire human race to be more sustainable, then how to educate people, young generation, is important so that that young generation can be able to discern how to teach AI.
Perfect, wonderful. And Kishan, what would be your remarks?
So I agree to so there's still some way to go before we can do like a very good, very accurate AI processing on board, completely on board. And till that time, there will be some level of manual interaction required to make sure that the decisions are not made wrong. And that's all. Yeah. So apart from just doing AI on, we need to make sure that the hardware for that and the making the data analytics ready also on board is something that people have to focus on.